Biodiesel is an alternative to typical petroleum-derived fuels. It can be synthesized from a variety of starting materials such as used vegetable or cooking oil. After some purification, these oils can be easily converted to biodiesel. Biodiesel can be used in regular diesel engines with little to no modification. Biodiesel can be made from more sustainable and renewable sources than gasoline, but it also produces less harmful emissions like nitrogen oxides, volatile organic carbons, and carbon monoxide.
Biodiesel synthesis is analogous to repurposing plastic waste. When you throw your disposable plastic bottles into a recycling bin, they're converted into new plastic products, like the polyester fibers in your shirt. Similarly, used vegetable and cooking oil that would otherwise be discarded can be transformed through transesterification into a new chemical fuel.
The synthesis of biodiesel starts with used vegetable oil, known as a triglyceride. You then add 3 equivalents of methanol and catalytic sodium hydroxide. The sodium hydroxide deprotonates methanol to form the alkoxide anion. This alkoxide anion then attacks the carbonyl group on the triglyceride. The carbonyl group then reforms, kicking off glycerin, a trialcohol, and 3 fatty acid methyl esters, which are the desired biodiesel products. The synthesis of biodiesel is relatively easy and straightforward. It only involves vegetable oil, methanol, and sodium hydroxide. First, sodium hydroxide pellets are weighed out. Then, vegetable oil is added to a stirring solution of methanol and sodium hydroxide. The mixture is allowed to stir at 50 degrees Celsius for 30 minutes. "30 minutes later, the biodiesel is ready to be isolated and purified. The mixture is added to a separatory funnel to separate glycerin from the biodiesel product. The 2 layers are allowed to sit in the separatory funnel for some time, so 2 distinct layers are formed. The biodiesel on top and the glycerin on bottom. The glycerin layer is then discarded. The biodiesel layer is then washed with DI water in order to remove any remaining soluble water impurities. Once again, the 2 layers are allowed to separate. The bottom aqueous layer is then discarded. And the remaining biodiesel product is dried of any remaining water using anhydrous magnesium sulfate. The magnesium sulfate is added and allowed to sit for a few minutes to soak up any remaining moisture. The biodiesel is then run through a filter pipette to separate any magnesium sulfate and obtain pure biodiesel. The end result is pure, usable biodiesel.